Okay, so here's just a quick review of what we did right before spring break. So just a couple things. First we did factorials, so make sure you know what they mean. So like 99 factorial would be 99 times 98 times 97 all the way down to 1. Your calculator is probably not going to handle that. So make sure you understand how factorials work. In math, you can always cancel factors. Like in algebra, you can't, remember in algebra, you can't factor like chunks, but if you factor it, then you can maybe cancel out, say you have an x plus 9 on here, you can cancel factors in that, but you can never cancel things that are added. So kind of the same idea here. If I give you like, oh, I don't know, 100 factorial divided by, say, 96 factorial, your calculator is actually going to try to multiply that out, and you're probably going to get some type of error. But if you write it out as factors, kind of like you did in algebra where you would factor it, so you write it out as factors. Okay, you don't want to write them all, but enough. And then you have 96, 95, You'll notice that all of these factors are going to cancel because 96 divided by 96 is 1. So what you can do on your calculator then is multiply those numbers to get the answer. So on a test, I might give you something where I want to make sure that you know how to, like, for example, just without using a calculator, how you could do the math. So if I gave you something like 6 factorial and then 5 factorial all over, say 5 factorial and then 3 factorial, and I said do this without a calculator, this would be 6 times 5 times 4 times 3 times 2 times 1. This 5 factorial is exactly the same. That's the only time you can cancel without writing out if they're exactly the same. And then this is 3, 2, 1. So again, you can't cancel these unless you write them out. So unless they're the same, obviously, then it'd be 5, 4, 3, 2, 1. So then without a calculator, I could do what? 30 times 4, it's 120, and I could get that. So make sure you know that. The other thing we talked about before break was permutations and combinations. So permutations, remember we want to think about photographs. And in photographs, order matters. Okay, so these are things like arranging art, arranging schedules, things like that. So say there's maybe, I don't know, like 8 classes that you could schedule, and you want to schedule them into, say you're going to take 4 of them, and there's 4 different time slots. Now, some of you might think order doesn't matter here, but again, not all of you wanted to take this class at 8 a.m. Some of you got stuck because of when you registered. Some of you did want to take it just because of life. So order matters here because you're scheduling. So this is a permutation. Okay, and the formula for that is everybody is in the picture. Subtract these to get the ones that you are canceling. All right, and you can put that on a cheat sheet. So I have 8 total. This is your total. So I have 8 factorial. So 8, and then I'm choosing 4 at a time. So 8 minus 4 is 4 factorial. And again, you can use a calculator with the P key to do that. If you don't have a calculator, you got to write it out. So you take 8, 7, 6, 5, 4, 3, 2, 1. And the longer arms, 4, 3, 2, 1. These would all cancel, and whatever you get here is going to work. But again, excuse me here, if I grab my calculator, somewhere in here. So for me on the graphing calculator, I'm going to go to math, go over to probability, and go to NPR. But first I have to type in my 8. So I go to 8, math, go to probability, and I'm choosing what, 4? And I get 1680 for that. So that's how many ways there are of doing that. Remember when we talked about combinations, that's when order does not matter. So a combination, I always like to think of committees. Because in a committee, we don't care who the committee is. You know, if A, B, and C are on the committee, C, D, A are on the committee. So here, order does not matter. Now, if I give those people jobs like president, vice president, and so forth, then suddenly order matters. So here the formula is, you have n choose r. It's exactly the same formula as the other guy. Everybody's in it. Subtract the people that are not in it. But then there's an extra r factorial in here to get rid of the double, triple counting, because ABC, CBA, BAC, all 6 of those combinations are all really the same thing. All right, so here an example would be like, usually the lottery order doesn't matter. I know on my math lab sometimes it will, but so like in a lottery, say you have, I don't know, 50 numbers to choose from, and say to win you have to pick, let's say just in general, you have to pick 6 numbers. We just want to know how many ways there are. We'll deal with probability later. So in this lottery, order doesn't matter in which the little ping pong balls get sucked up. So you have 50 numbers, you have to choose, I can't remember, 6. Choose 6. Now again, if you're going to do this by hand, you'd have everybody. You'd subtract these to get the ones that you're canceling, which is what, 44 factorial. But then you'd have this r factorial, 6 factorial, to get all the different ways in which, like 1, 2, 3, 4, 5, 6, 6, 5, 4, 3, 2, 1, 2, 1, 3, 4, 5, 6, all would be the same. But again, if you have a calculator, you don't need to do that by hand. So I'm going to go to math. I'm going to go over to, I got to type in 50 first. Then I'm going to go to math, go over to probability, go down to NCR this time, choose 6. All right, and then again, this is why I don't play the lottery. I think I got that right. 15,890,700. So that's how many different ways you could just pick six numbers. So that's kind of a review of combinations. Again, those, you can't have any repetition in either permutations or combinations. If you can have repetition, then the other thing we talked about, let me erase this quick, that we talked about before break was the multiplication principle. And the multiplication principle is what you use when you can have repetition. So you can repeat things. If you have repetition, you can't use permutations or combinations. All right, so this would be like, I don't know, like phone numbers, right? So say, how many different phone numbers could you have for the 4 digits? Well, you have 10 choices, because 0 through 9, 10 choices, 10 choices, 10 choices. So it'd be 10,000 different phone numbers you could have if you're just looking at the last 4 digits. Say we talked about computer codes. So say you're going to have, I don't know, maybe 2 symbols, and then you're going to have, what, 3 numbers, 3 digits, and then you're going to follow it by 2 lower or uppercase letters. Okay, so symbols on the computer, let's just say there's, I don't know, 15 to choose from. Okay, so because you have repetition, you could have asterisk, asterisk, or you could have exclamation point, so there's 15 there. Digits are 0 through 9, so 10, 10, 10, there are 10 digits. And again, the reason, if I could not be dyslexic here, is you can have 999 or 887, so you can have repetition. And then 2 lowercase or uppercase, so there's 26 letters in the alphabet, but if you can have upper or lower, that does 52. And again, the reason we call this the multiplication principle is literally you multiply all of these possibilities. Okay, and I don't know, this might be kind of big, so we'll see. 15 times what, 1,000 times 52 times 52. All right, and so I got 6084, and I think 5 zeros. 1, 2. Is that right? 608,400,000. And again, this is how many codes I could make if I wanted a security code. Okay, so that's a little bit of the review. Just a quick one. You're probably going to want to watch the My Math Lab videos, and then listen to me live when we get back together in class to review a little bit. And then I'm going to make another video on distinguishable permutations. That's the last thing we didn't do in class before break. All right, let me turn this thing off.